Hey guys, I just quickly graded those practice tests. For the real thing, I will take more time to grade, look into the answers a little bit more in depth, so I was kind of like going through these quickly. So you may have lost points because I didn't take the time to really understand what you were saying, but I will take more time tomorrow to grade. I just want to get you quick feedback before the test tomorrow. So question number 1, you all did pretty well on. That formula would be ClF, chlorine monofluoride. Part B was about half and half. So a lot of Lewis structures I saw looked like this. We had chlorine in the middle, 3 fluorines on the outside, and then you filled everyone's octet. Okay, so that is what I saw mostly of answers that were incorrect. The reason this is incorrect, even though everyone has a full octet, is remember that there are exceptions to the octet rule. One exception being that if you are in period 3 or lower, you can hold more than 8 electrons, valence electrons, in your Lewis structure. So how I know when you need to hold over 8 is I look at the total number of valence electrons that I actually have. So all 4 of these atoms are halogens, so they have 7 valence electrons. I have 4 of them, 1, 2, 3, 4. 7 times 4 is equal to 28. So I have to have 28 dots or valence electrons in my Lewis structure, and remember every line counts for 2. So right now I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I have only used 26 valence electrons. My central atom, chlorine, can expand its octet, so we would put 2 more electrons around it. So now it has 10 electrons around it, but that's okay. So this is the correct Lewis structure we were looking for part B. Part C, most of you at least got it half right because the answer is that it would be T-shaped. If you got it wrong, either you didn't specifically enough or directly enough address the fact that it would be T-shaped because the T-shaped molecule is asymmetric in terms of dipole moments, so the dipole moments do not cancel out but produce a dipole. Another acceptable answer is to say that if the molecule had a trigonal-planar structure, geometry, the molecule would be symmetric in terms of dipoles that cancel out to produce a net dipole of 0, being a nonpolar molecule, which is not consistent with the observation that it does have a dipole moment. Okay, so you specifically have to mention that in a T-shaped molecule, the dipole moments do not cancel out, whereas in a trigonal planar, they do cancel out. And part D was another one where a lot of people got like half the question right. So this key says that 1 point is earned that the student addresses both atomic structure and periodicity or trends in the periodic table. So you have to have 2 of these following ideas. The first being that you are going to have an odd number of fluorine atoms. The second being that as the atomic number, or as you go down a family, as the atomic number of the halogen increases, the number of F atoms around that molecule would also increase. So a lot of you mentioned one fact, but I didn't quite see the other explicitly, so I count it as wrong. But again, tomorrow I will be putting more time, more thought into grading these. So maybe you did state it, I just didn't get it right away, so I just marked 0. But again, this doesn't count for a grade. Hopefully you can see that feedback. Happy studying.